This is section 1.2, number 27. We've got a problem involving a ball being thrown straight downward from the top of a tall building. So we're going to start off with knowing that the ball is subject to acceleration due to gravity. So acceleration is negative 9.8 meters per second squared. The velocity is going to be the integral of that, so that's going to be negative 9.8 t plus the initial velocity, which I'm going to put as negative 10 because it is being thrown downward at 10 meters per second, so I'm considering down to be the negative direction, up to be the positive direction. And while we're at it, let's get the height. So the height is going to be the integral of that, so that's going to be negative 4.9 t squared minus 10t plus the initial height, which is actually what we're trying to find. Okay. Now we're told that it strikes the ground with a speed of 60 meters per second. The way I've set things up, 60 meters per second, that the ball is still moving downwards when it hits the ground, so that's actually negative 60. So what I'll do is I'll plug in negative 60 for v, and I'll find out what time does that occur. At what time does it hit the ground? So I'll solve this equation here. I'll add 10. I'll add the 10 over. I'll divide by negative 9.8. So 50 divided by 9.8 is about 5.1 seconds. And that is rounded. Okay, so we hit the ground at 5.1 seconds. We know that when we hit the ground, that means we're at a height of 0. So now what we can do is we can look at that position equation. We know that x is going to be 0 exactly when t is that 5.1. Okay, and then the only thing left, the only unknown in that equation is exactly what we're trying to find, the initial height of the building. Okay, so let's see if I do, I need to do some calculator work here. So negative 4.9 times 5.1 squared minus 10 times 5.1. Okay, so I get 0 would be about negative 178.5 plus x naught, and that tells me x naught must be 178.5, and that's in meters. So that must be the height of the building.